Good morning. So, as I was preparing for this particular panel, we knew that we had to watch the time. So, initially, as part of this mobile core-based panel, you can imagine that given that Intel collaborated with some of our operator partners as well as ONF teams to really bring what we are calling the next generation infrastructure core. This is the wireless core that we really developed as an open source platform working with all these people. I would have been really excited about the details of what we did and how we did it and et cetera. But since I have two of my colleagues following me, who probably are going to be a lot more authentic about how actually that is going to get deployed. So I will defer the details of NGIC to both of them. And then I started thinking about, I want to really talk about where we see the next frontier and what Intel would like to do in relation to that. And I didn't know that, by the way, I did not coordinate with anybody from Google on the presentation they did on the edge side. But I think they set it up perfectly well. Because from our perspective, we also believe that creating an open platform that really tackles all the challenges of this emerging edge is going to be a key. Because as you heard through last 3 days, what used to be the traditional cloud and what was the telco, they are all merging. And the edge, this evolving edge, is that paradigm, that space where these things are going to create some very, very interesting opportunities for everybody. So I'm going to really focus on how we go about doing that. So when we talk about this reimagination of the edge, one thing I just would like to point out is that it is not, from Intel perspective, it is not just because it's going to create these opportunities for cool technology development. I think it is rooted in this fundamental belief that there is going to be a huge business opportunity around edge as we move forward. So that is where, from Intel Labs' perspective, we have started looking at asking some of the fundamental questions. And I think Prajakta already talked about this, so I'm not going to belabor this thing. This thing keeps going back and forth, even though I'm trying to forward it. OK. So everybody knows that the definition of edge is going to depend on who you ask. However, we also know that everybody seems to agree on the fundamental drivers that are going to define how this edge really evolves. Latency, bandwidth, security, connectivity, all these are the fundamental drivers. So as we started looking at how do we make sure that we can evolve our platforms to accommodate all the different types of functions and features people expect from this evolving edge, given that these are the fundamental technology drivers for that. And we actually settled on the notion of visual cloud. So for us, the term visual cloud really means the processing of visual data at scale in cloud-like infrastructures. So this is where we believe that visual cloud is the most compelling workload that will allow us to really understand the different types of system partitioning challenges that will exist as you try to go from the data source all the way to the visual data sink. And there are going to be two types of these usage paradigms, from the data source all the way to the data sink. And some of the use cases you see in the bottom here. But simply put, one type of use cases will have lots of visual data coming in to the infrastructure. And when I say the infrastructure, I mean the edge to network to the cloud. Lot of visual data coming in, but at the sink, it is going to be consumed, or it is at least expected to be consumed by human eyeballs. Whereas the other type is where the lots of visual data is coming into the infrastructure, but it is actually going to be consumed by machines. So these are the two fundamental use cases that we would like to understand, build, and actually open it up for the community, so that as we are building these underlying technology platforms that you heard from everybody about, we can actually have meaningful use cases. And some of them you heard even in the previous presentation. Our goal is to really create these things, bring it to the open source community so that other people can enhance it, come up with new ways, new usage models, and that is what is going to accelerate this transition. So the first one that we are looking at is an immersive media use case, where we would like to deliver a 4 to 5 degree of freedom content to a wild field of view VR display. So if that is the goal, where if you look at today's content, essentially even if you are wearing a headset, when you move your eyeballs around or your head around, it is essentially a 360-degree view, and you are just kind of seeing different parts of it as you move your head. What we would like to do is really create that 4 to 5 degree of freedom so that you are actually recreating the light field in the space so that people actually get a more realistic sense of what they are observing. But to do that, we also have to, at the very front end, we have to change how the cameras are built. If you look at today's cameras, they essentially have enough overlap between adjacent lenses so that you can create that 360 view, but they don't have quite enough content to really recreate the light field so that you can deliver that 4 to 5 degree of freedom. So that is what we are working on. And by the way, as you create this new type of cameras, which are going to have a lot more overlap between the visual content, you have to figure out how you are going to compress them, because new compression algorithms will need to be generated, because you can't just dump everything in the infrastructure. Your connectivity issues are going to be the bottleneck. So we are working with the MPEG committees to really figure out how we create new compression standards for this kind of multi-camera content. And then, of course, as you can all imagine, there are going to be issues of low latency and high bandwidth if you want to bring some of this content to people who are in a stadium. And by the way, I should have mentioned that we are looking at a sports arena kind of use case as the proof point for our immersive media usage model, where we are going to have a real live video of a sports event that is being consumed at the other end by people wearing headsets. And some of this content you may want to transmit back to people who are in the arena itself. And then you have all kinds of different computation partitioning issues between all these different nodes that are in between the source and the sink. The other one, the video analytics use case, this is where we are going to have live video streams in a, let's say, a retail environment where people are really watching. There are multiple cameras in a retail store, and you want to analyze shopper behavior. So for that, we have a framework that will glean appropriate feature vectors from live streaming video and then really extract that data and metadata, store it in a graph-based store so that you can retrieve and do queries on it in a very easy fashion. And we are also going to build a query language. And that query language will not only configure your streaming framework, but it will also allow you to do very high-speed, low-latency queries onto that storage database. We also have the ability to do archival video so that you can do the same type of query on archives. And our goal is really to create this open end-to-end infrastructure where we bring our platforms, which are open platforms. You can add other heterogeneous elements, as was mentioned earlier, and then start building these different network functions in either virtualized or containerized fashion, working with the Chord community and ONF community. And then on top of it, some of the fundamental software framework building blocks so that we can invite a whole new set of developer community to come up with new ways to leverage this fundamental foundational platform that we are building. So that is the end goal that we have in mind. And we are thrilled that the same kind of ethos are being expressed by everybody else in terms of how we want to work together and accelerate the transition to this new paradigm. So we are really looking forward to it. I'm not going to continue talking because I know that Lyle Birds from Sprint has some very interesting things to say about how Sprint is going to take advantage of this next generation infrastructure core.
So good morning. I'm just glad I'm not the last group that's keeping you from lunch. So I want to thank the scheduling for that. I'm going to talk to you a little bit about what we're doing with MCore. But before we want to talk about that, I really want to talk to you about at least our architecture and where the mobile edge is for us. So our architecture is pretty straightforward. We don't have a local division, but we do have essentially a multi-tiered architecture. So at our tier 1 backbone, which we'll just call the internet here, we essentially communicate with the rest of the internet and connect through our dedicated internet access to regional sites. Now there's about 29 of these, and they really comprise today the EPC. So we're quite happy serving our 50+ million customers from these 29 physical locations. However, 29 doesn't cover all the US. So what we actually have is we have about 100 of the top market locations where we have essentially metropolitan area network rings. Now these were built in the 90s. And at those locations, we take usually one of the sites and we just refer to them as a satellite site. The primary role of the satellite site is to really introduce the metro area aggregation as well as the routing for this infrastructure. Now these sites also actually serve for our other products. If you use any of our wireline products, any of our products that have been converted from TDM over to VoIP, there's some infrastructure there. Now along this ring as well, we also have POP sites. Now these measure in the hundreds. And what's interesting about these POP sites is they range in distance from anywhere of just a few kilometers to about 20 kilometers from a eNode B. And soon, as we've announced, we're deploying 5G, so you're going to see those hybrid eNode B, GNode Bs as well. Now, what's interesting for us is we are also trying to push RAN virtualization. So one of the things that we're really kind of struggling with is where do we actually put the edge app? And so as we try to centralize more stuff, back toward the POP, and in some cases, based upon the topology, it's actually pushed back toward the SAT sites. We really don't obviously want to push our app further out. So when we talk with customers, what's interesting is depending on where they're at and what they're asking for, it may be better, when we consider RAN virtualization, to actually put them on the other side of the radio and actually put it and consider a local customer prem deployment. But that's a case-by-case basis and in an engagement. So the bigger question here is, why would we do this at all? In today's world, we're actually quite happy and content with serving everyone from the regional sites. And we do have a few motivators. So obviously, we've talked today about the applications and if the loop really requires this. But one of the more interesting ones for us is, because we've really pushed into so few sites, we do have some sites that we feel are too big to fail. A lot of those people will think too big really means that there's too many customers, but more likely what's happening for us is a site is serving so much traffic that it doesn't make economic sense to have a backup site being capable of serving that. So a good example is, if we have a site pushing over 1 or 2 terabits and the local backup regions basically have great connectivity, but we don't want to invest in having an extra terabit of capacity sitting at those sites, then it just makes more economic sense for us to start pushing out toward that edge. The other driver for us is really the service customer request. What's interesting about that is it's not the initial app, right? The initial app that has to be at the edge, but when the customer requests that their apps are close to those apps. So a good example is if you were doing an AR/VR and there's a customer who actually is providing services in support of that AR/VR app, right? We would co-locate. Not because those services may really need to be close, we just want them closer to the app, or the customer wants it. Another series of applications that we're looking at, right, is industrial IoT. So we totally understand that robotics and everything else needs to be there, but a lot of the enterprise apps, because of the private nature, also need to be co-located. So don't necessarily think about that edge serving things that need a tight control loop and low latency. Think about all those extra apps that support those apps that need to be co-located with them. So we've been looking at MCore Projects for a couple of years, and we're actually heavily developing it. And we're actually doing this with the edge in mind. So we talked about this on Tuesday, and I'll just kind of briefly go over this. These are the actual new repos. Right now, they're closed down with help from our partners at Intel and GS Labs. We're going through license checks, and we're going through security checks. And so you see kind of in the boxes the various repos and the names. The MME was a part of C3PO. Now it's a standalone project, Open MME, developed by Intel and GS Labs. And then we have the NGIC, now a new version called Run to Completion that actually runs on a 4-core solution. So it's actually a much more efficient item. And we have 2 other cores now running Linux. So you can pop on your favorite control plane protocol. Or, scarily enough, if you feel like your Linux system administrator can run your routers, go for it. So we've got quite a few upgrades. And so we've actually been pushing this for the last couple of years. And your out-of-the-box experience, we call it a frame. A lot of people used to ask us, what's the smallest size if I want to try a full EPC? So we balanced being too large. So our recommendation, if you see the demo, is 100 cores, because there's traffic generators in there. But we typically recommend 42 to 82 CPU cores. You'll get about 1,000 TPS in the control plane. If you're running this in like North American numbers from like 2014, 2015, that's roughly equivalent to about 3.1 million users in terms of control plane signaling capacity. But we recommend for your simulators only emulating about 40,000 users right now. And that's kind of your out of the box. So we want to make sure that if you actually downloaded all this code, that it wasn't a toy, you don't stop at 3 users or 4 users. But we also didn't want to put you under the burden of having traffic generators generating hundreds of thousands of users. So we felt this was kind of a good out-of-the-box experience. And as I said, right now the repos are closed. Once we get past those security scans and stuff, we'll open those back up. So you guys will have a very clean base of code to work from. Part of the reason for that was we wanted to go to production. The other thing that we wanted to do was we wanted to make sure that we actually improved the way we're coding, as well as the overall quality of the code. We talk a lot about the functions, but a lot of what we do at Intel, Sprint, GS Labs on these projects is we actually focus on the initial input, the spec. We have a system that basically pulls from Word docs, and I'm sad to say it's written in Visual Basic, so nothing too exciting or sexy, or text files, pulls those specs in, actually validates that they're actually meeting some basic sanity for the information model. And then we actually put them in an intermediate language. So in the case of diameter, we put it in something called a dia format, which is based from an Orange project. In the case of some other stuff we'll talk about in a minute, we put it in Yang. And the reason for that is we're going to force a cross-compile. And what we're really doing here, guys, is we're looking for quality. What we have found to date is over 4,000 errors in roughly about 40 documents from 3GPP and the IETF. And so we're in the very long process, if you can imagine, because you have to submit a change request sometimes for each individual error. We're in this very long, slow process of going back and correcting those. Now, what's nice about this is actually used to generate both AI testing software and test frameworks, and it's also actually the code now that's generating most of the stuff in MCore. So when you look at the MCore projects that we're on, your diameter base stack, not the behavior, the base stack is actually generated from this. And I'm happy to say we now have the GTP working for that, and we've also picked up the SX protocol. So we're doing quite well with this. The nice part is an engineer can, if it's I'll say challenging spec, it may take 20, 30 hours to actually bring it in. If it's got a lot of errors, or my other favorite one is, guys who write in Word documents don't understand circular dependencies. So that's always fun to kind of parse through. But basically, our median time is around 90 minutes of bringing in something, generating and running a new interface. So this is really one of the biggest pieces, one of our original motivators. We wanted to get functions from spec to code as quickly as possible and still maintain scale. So I'm just going to kind of close with this. So the road ahead for us is that we actually are now generating the GTP. The SX validation's done, so we'll be generating that. We'll be picking up the non-access stratum system. So what's important about that, guys, is these are most of your major protocols that are coming in MCore. On the EPC. And some of this stuff, like SX and stuff, is also in 5G. We're actually expanding our current test generation frameworks to actually support any protocol. So basically, you give us a PCAP of a single message, and we let the AI basically run with that and do the rest of the work. The 5G side, we talked about on Tuesday that we're enhancing RTC to support SX. And N4, they do, right, the N4 does use SX, but I want to remind people there's some changes coming, so we do expect a little bit of a split. And we also announced option 3X support. So you will have MCore supporting that hybrid mode of option 3X. Now, in terms of readiness, and this is really important for us, we're making RTC a UPF. So we're getting it ready for production, and we're actually going to talk about field testing here in a second. The other thing that's important about this is free is not free. Right? A lot of people think you download code, and it's on an open source license, so I don't owe anyone anything. However, there are IPR licensing, other things that apply. And so we're working with partners like GS Labs and others to basically help you when you download the code and decide to take it to production to understand what those fee schedules are. And by the way, we're talking about tenths of pennies per user, those sort of things. Not a large fee schedule, but you need to navigate that so that you make sure that you're compliant in every respect when you go to production. We feel that's important. On the research side, the next-gen core, as the specs get finished over the next year, we'll start looking into that. So look out for either, we haven't really decided, either the same repos or different repo names, different projects. And we're actually meeting the 4G scale and feature testing. So one of the things that was on the slide before was we use Cassandra. So the system actually in its current form can hold 1 billion user entries in the single key space. And we have a design that goes about 10 to the 18th in terms of a 2-tier design. So we're looking at hopefully Intel lending us a lot of hardware in 2019 to do a little bit more testing. And finally, I want to close with this. So at Sprint, we're exploring using our MCore projects that we've developed with GS Labs and Intel for Edge, with field trials expected next year. And that's dependent right now on third-party availability of Edge applications. So this is this is not exactly the right venue in some sense, but as we think about more of these applications, those sort of things, please send folks our way, because we want to get out there. We want to get this code into a field trial as quickly as we can. So with that, thank you very much, and I'm going to hand this off to Oz.
All right. Hi, everyone. My name is Oz Sunai. I am with ONF, Chief Architect for Mobility. So I will spend a little bit of time talking about where things are going within the ONF community with regards to mobility. Pranav and Lal talked about the edge in general, and effectively they talked about why we need the edge and where the edge potentially is. But from a functional perspective, now that we understand those, what really is inside the edge is also another question that we need to answer. So this takes us to 5G. 5G, of all the 3G standards, is different in an economic sense. It is going to be a new business enabler. It is going to create a new value chain for the telcos. So we're talking about economy. Basically, economy in our context dictates that we should distribute where we must and pool when we can, and do this using all cloud principles. So this requires clearly virtualization, disaggregation, and so that we can start talking about distribution. In the telco context, in 5G, that means we are going to need to virtualize and then disaggregate the radio access as well as the core network components. But at the same time, like Lyle said, we also need end user services that would be residing at the edge. So then an edge platform is an environment where the virtualized RAN components, the virtualized core network components, as well as the end user services that require certain use case specific requirements, such as latency or locality, to be coexistent at an edge cloud, at an edge platform. In addition to all of this, some services, as Lyle said, very openly, Sprint wishes to actually go to production, and he's asking for services, which automatically means we don't necessarily know what the killer apps are. And this is going to evolve over time. So that means the platform needs to also allow for rapid innovation of new services. This requires programmability, and programmability of the access, programmability of the network, as well as programmability of the service graphs that you need to create for a use case basis. So we have, you have heard this many times over the last 2 days. At ONF, we have been developing Chord as the edge cloud platform where the programmable access meets the cloud. So in that context, in our Chord platform, we're talking about a platform where distributed RAN components will be there, some core components will be there, and some edge services will be there, and also the controllers that control the access will be there. So now let's zoom in on the edge. We talked about the mobile connectivity and the need for a distributed network to support the new use cases. But the telco edge is also a location where other technologies will meet the cloud. For a telco providing both mobile and broadband connectivity, the edge cloud will also host components of a programmable access and core for the PON. With programmable multi-access at the edge, this means telcos will now have the opportunity to provide connectivity as a service on their platform. This means that we need to host distinct user plane functions at the edge, one or more per access technology. And the distributed and the cloudified vision potentially means some of the access-related network functions, as well as some of the end user services or components of these services reside elsewhere, either in neighbor edge clouds or in a telco cloud or in one or more of the public clouds. This means the edge cloud platform needs to enable multi-cloud connectivity as a service as well. So with that in mind, moving forward at ONF, the MCore work is really transitioning towards two distinct reference designs. And the first one is focusing on the network functions that enable connectivity and access in a multi-access fashion. So I talked about distinct user planes residing at the edge. The first thing that we are going to do in this case is zeroing in on what Lyle talked about, the open source EPC. So we have already, as you've heard, thanks to Intel and Sprint, we have a number of repos that will be open in a short little while, and you will have access to a near deployment grade EPC on your hands. But we are going to actually continue the evolution of that. And now, actually, with an explicit request for a minimum viable product centering around a lightweight open source EPC for a fixed mobile use case, Deutsche Telekom intends to actively participate in this evolution. And here I'm officially making a call for participation towards this goal in the ONF efforts, pointing to a really tight timeline. The second phase here is I talked about three distinct user planes. It is going to focus on converging these different user planes we have at the edge. The user planes of the cores of the different access technologies, and also user planes of the virtualized RAN and the core in the mobility case. And we will use ONOS here to programmatically match active flows with their corresponding access-specific control planes. And the third phase of this work will then focus on converging the control planes. So you may know there are discussions on this front, both in BBF and 3GPP. In coordination with those efforts, we intend to converge the control for authentication, subscription, and session control for the different access technologies, but at the same time, the control of some access-unique functionalities, such as mobility, could be handled separately in this context so that we have an efficient control mechanism. And the second reference design moving forward will focus on the multi-access edge. You heard about an hour ago Larry detailing this, so I will very, very briefly overview this again. We mentioned that there is a need for multi-cloud connectivity. This multi-cloud connectivity is not just because we're distributing the network functions of the telcos, but it is also for end user services. As you know, with the cloud paradigm, services are going towards a microservices architecture. So that means the services themselves are going to be distributed as well. So the cloud, the edge cloud, be it telco-owned or owned by someone else, will need connectivity to both the centralized telco cloud and also to all of the public clouds. So on this front, we are investigating mechanisms where we can enable the creation and operation of subscriber-specific service graphs across multiple clouds. The desire is to ensure proper operation regardless of the ingress technologies that are in place in different clouds we wish to connect to. This takes us to the investigation of service mesh, as you heard from Larry, effectively providing a means for a layer 7 SDN to interconnect the services on either side of the multi-cloud boundaries. So this hopefully gave you a very brief summary of where things are going on the mobility front. So let me take this opportunity to make an open call for active participation in the technologies that we will be pursuing moving forward and towards two distinct reference designs. Thank you.